Okay, we're going to look at section 2.6, number 6. It's evaluating a limit involving trig functions. You can see we've got sine of x and secant x here. So the limit as x approaches 0 of this whole expression. Now, for trig functions or any function, if I'm taking the limit, if I can, for us, if we can plug in and get a real number, then that limit is continuous at that point because the functions that we deal with are continuous on their domain. And so if I plug in directly and get a real number, then we're done. Problem is if I plug in 0, sine of 0 is 0. So the top is 0. And of course, 3 times 0 is 0. We get this form. And remember, this is indeterminate, which doesn't mean the limit doesn't exist. It means more likely we've got a hole in the graph for this function, and we've got to do some work. Now, what type of work are we going to do? Well, there's a very important limit that we know. I derived this one in the lecture notes using the squeeze theorem. But you should know this one. In fact, this limit is actually on the help sheet that I give you. I give you an algebra and trig help sheet. Under the trig help sheet, you will see, in addition to all the fundamental identities, you'll see the right triangle definitions, and then the unit circle. But right above the unit circle, you'll see these two limits here. And these are the two that we prove in class. You will have these on the test and you can make use of them. Now, of course, notice they were using the variable theta in these, and that's okay. I wrote it in terms of x here, so you'll have that limit. And we just need to apply one or both of these limits a lot of times when we have these indeterminate forms of 0 over 0 involving trig functions. So I just look at this and this is the one I know, and I can see it. I'm sort of outlining. I see it in there, right? I just need to pull that out. And the way I pull that out is to factor the sine of x out, so to speak. I'm going to break this function into a product of two functions, right? So I've got sine x over x, and what's left? Secant x over 3, okay? So I've just rewritten this is all. I'm still taking the limit as x approaches 0. Now the limit of a product is the product of the limit of those two functions, right? And this one, provided these two limits exist, very important. And we know this limit exists. We just talked about it, right? The limit as x approaches 0 of sine x over x is indeed 1. What about this one? What's the limit as x approaches 0 of secant x over 3? Well, this function is continuous at 0. If I plug in directly, I get secant 0 divided by 3. Secant of 0 is 1. I get 1/3. Why is secant 0 1, by the way? Secant of 0 is the same as 1 divided by cosine of 0, right? That's that reciprocal identity we're making use of, right? Right here. And then we know that cosine of 0, right? Cosine of 0, cosine is the x coordinate, right, of the point. So cosine of 0 is 1. And so that's how we're getting that secant of 0 is 1. At any rate, we get 1/3 here. So I get 1 times 1/3, which is 1/3. And that's a long drawn out explanation. Very simple though. And that is our limit. The limit is 1/3.